Yes, good morning. It's candidates or candidates for that matter. Assalamu alaikum wa rahmatullahi wa barakatuh. Usual, Mr. Chitanbe is going to share with you a new topic that is current electricity. Specifically today, we want to handle electric cells. And electric cells is one of the sources of EMF or electricity for that matter. We have other sources of electricity or EMF other than electric cells. For example, we have thermocouple meters, we have other sources of EMF like magnetic sources and so on. Specifically, our interest today is source of EMF that is to do with electric cells. Now, electric cells wait a bit. Okay, we are sorry for that technical interruption. We are back to our study of current electricity and electric cells for that matter. Now, what do you mean by electric cells? We say these are devices that produce electricity by chemical action. Electric cells are devices that produce electricity by chemical action. We have other devices that produce electricity by the other sources that do with electrical method, other sources that have to do with magnetic sources, and others. Specifically, our interest are sources of electricity that are from chemical action or chemical reaction. Now, I have many types of electric cells. One, simple cells. dry cells, wet cells, lead acid accumulators, which we call the normal common batteries, and then the alkaline cells. So the scope of our study today is just going to rotate about those cells only. Now let's straight away begin with the first cell, which we call the simple cell. Now this simple cell consists of two plates, the zinc and the copper plates, which are dipped in dilute sulfuric acid. The sulfuric acid is acting as an electrolyte. The zinc plate is the negative plate, which we call the cathode, and then the copper plate is the positive plate, which we call the anode. Now, the major question here, how does it work? How does it bring about current and therefore formation of current electricity? Now, we are going to realize that within our electrolyte, there is sulfuric acid, which ionizes in solution. Sulfuric acid ionizes in solution to produce hydrogen ions and sulfate ions. So when we bring in some of these equations, don't worry much. There is some chemistry that is coming in because of chemical action. But for us, majorly, we are not about the equations. We can use the equation for explanation, but in a paper, we cannot tell you to write the equation. We're only interested in you getting to know the fact that they are coming from a chemical reaction. Then, the copper plate is connected to the zinc plate by a wire, and the zinc plate dissolves in the acid to release two electrons. So the zinc in a solution dissolves to produce zinc 2 ions, and 2 electrons are released. Now these released electrons, you're going to note here from our supply, we have that plate within the electrolyte. So this is the zinc plate, and then this one is the copper plate. Then the 2 electrons after ionization of zinc are conducted through the wire and then joined to the copper plate. That is the first step. Then the second step, the hydrogen ions here migrate towards the copper plate to form hydrogen gas. So within this solution, we have hydrogen ions that are released from the ionization of the acid. They migrate towards the copper plate in order to complete the circuit. So the hydrogen ions, they join these 2 released electrons from the anode here to produce hydrogen gas. Now, you are going to be seeing bubbles of hydrogen gas, of a colorless gas, deposited onto the copper plate. Now, after completing the circuit, electrons go into the copper plate, hydrogen ions meeting the released electrons, the circuit is complete, then current flows in the conventional opposite direction to that of the flow of electrons. And therefore, the voltmeter, usually we normally use a galvanometer or millivoltmeter, because the current that we produce is very small, and the current is about 1 volt. Therefore, After completion of the circuit, the voltmeter deflects, indicating that current has been produced, or there is a PD that has been developed, and therefore this is a cell that is producing EMF. In brief, we are saying this is a simple cell produced through the ionization of the electrolyte, producing hydrogen ions. Then the zinc dissolves within an electrolyte, produce the two electrons. The two electrons are allowed to go through the external circuit up to the copper plate. Then at the copper plate, the electrons merge with the hydrogen ions released in solution to produce hydrogen gas. So the circuit is now complete and therefore current flows. So the voltmeter deflects. And we are saying the potential difference between the two plates is the one that creates the PD. So that's how, in brief, how a simple cell works. You may be asked, with the aid of a diagram, describe how a simple cell works. Now, when they say describe how a simple cell works, you may not tell us a simple cell consists of a copper plate, anode, whatever. You just begin with how it works. You tell the mechanism of conduction that brings about current, what? Electricity. Is that one okay? And sometimes they may be told, with the aid of a diagram, indicate the direction of the flow of current and the direction of flow of electrons. You will indicate that the direction of flow of current is here, is conventionally opposite to the direction of flow of electrons. Why? It is because the electrons firstly flow, complete the circuit, then current flows. Because current flows in a complete circuit. So it is these electrons that move from one plate to another, and then through the electrolyte, when the circuit is complete, then current flows. So the conventional flow of current is opposite to the direction of flow of electrons. That one okay. Now we go to defects of the simple cell. We are going to note, by the way, this simple cell, we can also use a lemon juice. You know lemon juice? You can just put one nail on one other side and then you use another opposite nail on the other side, and then you join them to a voltmeter. It will deflect. It's also an example of what? A simple cell. You can make a simple cell from simple lemon juice. Make your own simple cell. I get it. I even saw one person was it over WhatsApp. He used to charge his phone using the lemon cell. Because the charging of a phone is using small amounts of current. Just used and then connected the charger, then connected the thing, started charging using a simple cell. Okay, now we go to defects of a simple cell. You know, defects is some weaknesses that are really developed within a cell. You are realizing that this cell cannot work for life. It works for a certain period and then stops. Are you getting it? And what are the major causes of this defect? There are two defects. One is polarization. 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 That is the first defect. What is polarization? Polarization is the collection of hydrogen bubbles at the copper electrode. Collection of hydrogen bubbles at the copper electrode, which partially insulate the electron. Which partially what? Insulate the electron. So when they insulate the electron, it implies that these electrons are not reaching the electrode directly. And therefore the conduction of current goes on diminishing after some time and then it stops. I get it. So we're saying polarization is the collection of hydrogen bubbles at the anode, or you can see if you don't use the word anode, you can use the copper electrode, which partially insulate the electrode from the electrolyte. Partially insulate The electrode from the what?
Electrolyte.
Electrolyte. Remember, what is the name of the electrolyte we are using? Thank you so much. It is sulfuric acid. So it produces a coating around the electrode such that the sulfuric acid is no longer in contact, and therefore the circuit is going to be cut off, and therefore it will deteriorate and eventually stops working. Now, how can we prevent or reduce polarization? It can be reduced in two ways. One, occasional brushing of the anode. After using it for some time, you get a brush and then you remove that hydrogen bubble coating so that it is fresh to receive no other ions. That is one. Occasional brushing of the anode. Two, adding a depolarizer. Adding what? A depolarizer. What is a depolarizer? A depolarizer is an oxidizing agent. It oxidizes the hydrogen to water. So when you add the depolarizer, because you know it is going to be like the potassium permanganate, manganese oxide, that is going to oxidize this hydrogen, hydrogen ion. The equation may not be necessary said here. So the hydrogen gas is going to be oxidized to water. I don't remember the stuff for water. I think this needs water. So the hydrogen bubbles, they were coating that was coating on the anode is oxidized to what? To water, and therefore to be removed. And that is the effective method of cleansing. So then, therefore, it may work for some time before getting deteriorated. So that is the first defect. The second defect is called local action. Local action. Local action. They're saying local action is the gradual wearing out of the zinc plate due to impurities present in the plate. Due to impurities present in the what? In the plate or on that electrode. The impurities react with the acid. You know, zinc is not pure metal. So the impurities react with the what? With the acid. And sort of corrode it, goes on wearing out like that. And then eventually stops the function of the cell. Now, how do you prevent local action? We can prevent local action by adding concentrated sulfuric acid and then rub it with mercury. Adding concentrated sulfuric acid and then rub it with what? You add concentrated sulfuric acid and then rub the electrode with what? With the mercury. So the combination of zinc, mercury, amalgam is a combination. Amalgam covers up the impurities. So the impurities will no longer be in contact with the electron, and therefore will not be reactive with it, thereby preventing their contact with the electrolyte, and therefore polarization with local action is prevented. Any question as far as the two defects are concerned? So you say yes? No, we just pour on the electrode. We pour concentrated sulfuric acid on the electrode, and then we rub some mercury on it, such that we seal the electrode from the electrolyte. All right. Now, advantages or prevention of local action is now clear. Now, disadvantages of a single cell apart from local action of polarization. We have other disadvantages of this. When you look at it, you can even see the disadvantages. Apart from local action and polarization, one, the acid is corrosive. The acid which you are using is what? You know what I mean by corrosive? When you pour it on your skin, it wears out of the skin. And it is open, therefore it can spill over. When you're using it, you may not be careful and you just dump the electrodes inside, and then it spills over. And then once it falls on your skin, it will corrode the skin. That's what happens. The hydrogen gas produced is highly flammable. Hydrogen gas produced highly flammable. And you could say the setup is open. And therefore, if there is any heat somewhere, it can burn. It can burn. So those are risks involved. The third one, it may not be easily portable. Okay, portability in terms of size is not big. But the challenge is that its fragile nature in terms of arrangement can make it inconveniencing in terms of handling. And therefore, it may cause some problems. So those are the key things as far as the simple cell is concerned. Now we go to what we call Lakeland cells. Lakeland cells. Lakeland cells. Now Lakeland is the person. The person is there. Having studied a simple cell and realized that it is coupled with a lot of weaknesses. First of all, there is polarization, there is local action, acid spillover, because it is a liquid, and all of those ones. He said that we need to make an improvement in the simple cell, and then produce what we call the Lakeland cells. Now, the Lakeland cells, there are two types of cells. That is the wet cell and the dry cell. So it is Lakeland who invented the dry cell. I get it. But did not begin with the dry cell. Began with wet cell. These days, wet cells are not common because they were phased out by the same person who made it. I get it. But you may not understand how we come about a dry cell when you don't know wet cell. Now, this wet cell may be tough to draw, but it is having inside it, there is this black line inside, and that is what we are calling the carbon rod. Carbon rod, when you see positive, it implies that this is the positive electron. And then, when it is made of carbon, this time around. Whenever we talk about carbon here in electricity, we are not talking about diamond, we are talking about graphite. Because graphite is the only conducting allotrope of what? Of carbon. So it's a carbon, we are meaning graphite. Then we insulate it, we put it in an electrolyte. And the electrolyte this time around we're using ammonium chloride solution. Inside here, we first place it in the manganese oxide. The purpose of manganese, what do you think is the purpose of manganese oxide inside here? Yes? What is the purpose of manganese oxide? What is the purpose of manganese oxide? Eh? Eh? Yes, you said manganese oxide acts as a depolarizer. Ammonium chloride solution here is the electrolyte. Because we noted that when we are talking about the disadvantages of a simple cell, we are using sulfuric acid, which is corrosive. Here I have now changed. Instead of the sulfuric acid, we are using ammonium chloride gel solution. Then we are using the carbon as an electrode, a positive electrode. And then we are going to be using zinc plate as a negative electrode. If we use a zinc rod, you can put a zinc rod here. And then you can cover the container here. So we have a mixture of carbon and manganese oxide inside here. Act as a depolarizer. The carbon rod is the positive plate, and the zinc, as usual, is the negative plate. You know why we are using zinc? For more chemistry, yeah? What you call the reactive series, yeah? More reactive metals. So zinc is one of the easily reactive metals. They easily lose their electrons. And that's why it's regarded as a negative plate. Because when it loses electron, it becomes, the source of electron, that's why it's negative plate. And this is the receipt of electron, which is a positive one. This is a positive plate. Now, how does it work? That is the structure. But we also have what we call a vent here. I'm just drawing a rough one. A vent is just an outlet. And the rest here is ammonium chloride solution. The clear diagram, you'll see it in the notes here. So we are now saying that how does a wet cell work? How does a wet cell work? Now, I said first of all, the manganese oxide inside acts as a depolarizer, although the depolarizing action is slow. Hence, there is some little polarization that still works. So it produces less current. The current produces not to the required quantity. Now here we are having a chemical reaction that produces electricity. We have the zinc chloride that is producing zinc ions. I'm going to write on the ionic equation. Now the zinc will be reacting with ammonium chloride, produce zinc chloride and ammonia and hydrogen gas. We're not going to write that long equation. I'm interested in this equation of zinc ionizing in ammonium chloride to produce the zinc ions and the two electrons. And it is these two electrons that are produced that connect to the positive plate in order to complete the equation. And once the equation is, complete the circuit. And once the circuit is complete, then current flows. The ammonia dissolves in water present in the polar spot and eventually escapes through the vent. Because there is hydrogen gas produced in the equation of ammonia and zinc. There is ammonium chloride, ammonia, and hydrogen gas. So the hydrogen gas is allowed through the vent and escapes. So the electrons released after the zinc dissolved in the electrolyte moves to the carbon rod, and this leads to the current flow in the reverse direction of the electrons. So the electrons, once they are moving in this direction, then current flows in the reverse direction. So that's how a wet cell works. Now you are going to see before we go to the dry cell, the working of the wet cell is going to be the exact working of the dry cell, as you are going to see. But before we go there, any question as far as the wet cell is concerned? I say manganese oxide acts as a depolarizer. Key points. 2. Zinc dissolves in ammonium chloride to produce the 2 electrons. The 2 electrons vibrate through the external circuit to the positive electron, which is carbon. And then the zinc dissolves in water to produce the 2 electrons, and this leads to current flow in the reverse direction. I'm saying the reverse direction, electrons are moving in this direction, current moves in the reverse direction. Is that one okay? Now, we go to the dry cell, the second cell of the plant. The plant, I said, is an individual who produces 2 cells, and it's making the solution 2. Now we have realized with the wet cell, there are some problems here we're experiencing here. 2, the cell is open, so it can spill over still. 2, you are noting that we are producing less current due to slow process of polarization, and therefore less amount of current is being produced. And therefore, we needed to make an improvement in the wet cell. And that one brought up what we call a dry cell. The process, the action remains. The only thing that are changing here is that instead of using ammonium chloride solution, we are going to be using ammonium chloride jelly. We're using a jelly instead of what? A solution, because the jelly cannot pour like the way the solution pours. It's thick, so it cannot pour. I don't know whether you have ever opened the dry cell. You see that jelly, thick liquid, actually thick material. The second thing, instead of just using an electrode like this one, or a zinc electrode, we make the can itself made of zinc as a negative electron. By getting the can itself, so that is not staggering within the liquid. It is fixed. And the carbon rod, instead of using carbon as an electrode, positive electrode, we are now changing to brass. It's using brass. I mean, we are using carbon rod, but covered with a brass cap. Carbon rod using a brass cap. So the diagram is as you see it there. Now, the process of mechanism of production of current is the same. How? The zinc dissolves in the electrolyte to produce zinc ions and the 2 electrons. And the 2 electrons move to complete the circuit, and then current flows. The hydrogen gas produced collects at the carbon and is polarized by the cell, because we have a depolarizer still manganese oxide. Then we are saying the manganese oxide oxidizes the hydrogen to water, and the cell continues to supply current for some time before it runs out. So now, if that is so, why is it that after using the dry cell for some time, it is completely used up? Completely what? Yes, because the process is a chemical reaction and it's not a reversible reaction. Once all the ions within the electrolyte have been used up, then the cell ceases to work. And we also said that local action may not be completely removed in dry cells. Therefore, it deteriorates for some time. So advantages of a dry cell over a simple cell. One, the dry cell is portable. The dry cell is what? Portable. Its electrolyte is in jelly form, and therefore cannot pour easily. Now, so far, the cells we have covered, simple cell, dry cell, wet cell. All those cells are called primary cells. They're called what? Primary cells. And those ones which we have not covered, that is lead acid battery. The acid batteries used for vehicles and other uses. And also alkaline batteries, these that are used by laptops and so on. Those are secondary cells. Now the major issue here is, what are primary cells? What are primary cells? What are primary cells? A primary cell is a cell in which the current is produced as a result of irreversible chemical reaction. Irreversible chemical reaction. And therefore cannot be recharged when it runs out. When your dry cell runs out, you cannot recharge it. It works at once and then you throw it in the dustbin. You're going to say, how about these people who dry the dry cells and they start working again? We are only fighting with the polarization. They are only, instead of rubbing, they are only wiping off the hydrogen dust that has covered the electrode, and therefore can only help it to prolong for some little time, and then after that, even if you dry 1,000 times, otherwise they cannot be recharged because they have irreversible chemical reaction. It is formed by irreversible chemical reaction. These include simple cells, dry cells, and wet cells. All those ones. And then secondary cells. These are cells produced by reversible chemical reaction. Reversible chemical reaction. And due to the fact that they are reversible chemical reaction, we can recharge them. We can do what? After, when the battery runs out, you go to the battery charger and then you recharge. But these days, even battery charging thing is becoming of almost no use. Because most of the vehicles have capacitors. They have what? Capacitors. So, when the vehicle is moving, the battery is recharging. Yeah? So as long as the vehicle is moving, you don't need to recharge. It recharges itself. But if you let the battery of your vehicle and stay there for a month, then you need to take it for battery charging because it has not been charging. Or you do switch on the vehicle every after a week. You remember how the taxi people were suffering after the lockdown. Hmm? They had to go and recharge the vehicles again because they had rested them for a long time, and therefore the battery has lost the charge. But the good thing, they can be recharged. So those are secondary cells. So how can it be recharged? We are going to see the process of recharging. But this is made, we only pass the current in the reverse direction through the same cell. So that the direction of the chemical process reverses, and therefore the battery can work again. So these are lead acid accumulators. These are the normal batteries. And nickel alkaline cells. So these are what we normally call alkaline cells. And they are also what we call lithium cells. But lithium cells are not on our syllabus. But lithium cells, these are new technologies that have come up with the planes and so on. For them, they use lithium cells instead of using these simple cells that we are using here. All right. Now, this has brought us to talk about the lead acid accumulator. Lead acid what? Accumulator, all these common batteries. They are two terminals. There is a positive terminal and a negative terminal. But we have many plates inside. The plates are many. I don't know how to draw them very well. On this side. So we can have a positive plate and a negative plate. The electrolyte is the loose sulfuric acid. This is dilute sulfuric acid. And then this just we normally use a plastic container here. Then the positive electrode is usually lead to oxide. Lead to oxide. I have forgotten some chemistry. And then the negative plate is what we call lead. The negative plate is the lead. How do they work? Then we are saying the lead acid accumulator supplies, of course the working is the same, in the sense that the lead ions, the lead dissolves in the loose sulfuric acid to produce lead ion from the electrons, and then the electrons move through the external circuit to produce so the hydrogen ions migrate in the reverse direction to produce some hydrogen gas, and then current, since the circuit is complete, then current flows. We are saying lead acid accumulator supplies much more current than the dry cell, because for it, instead of having one cell, it has, do you know what we call accumulators or battery? Battery is a group of cells. It's a group of what? Cells. Now there are many plates inside. Each of it is producing the electrons, and therefore the recycling process is having a lot of current that is getting produced other than a single cell that we saw in a simple cell. So when it's fully charged, the relative density of the electrolyte reduces from 1.25 to 1.1, and that is when it is fully what? Discharged. Full charge, the relative density is 1.25. Then once it is discharged, it's 1.18. So once it is discharged, then you can take it for charging. Advantages of a dry cell. One, it can be recharged when it runs down. It has low internal resistance due to closely spaced plates. Produces stable and relatively high current. Material used to make it achieve. So those are the advantages. Disadvantages: it is very heavy and not easily portable due to heavy lead plates. Even lifting it, you find a hard time. Sulfuric acid can spill and is very dangerous and can cause burns, but usually fully covered to ensure that one does not happen. Then hydrogen and oxygen produced, because here in the production here there is some oxygen that is produced, are highly flammable, putting the user at risk. Then it requires a lot of maintenance. You need to do a lot of maintenance, as you are going to see how you can care and maintain the lead acid accumulator. So care and maintenance of the lead acid accumulator. 1. The lead acid accumulator can be used for a long time provided the following are taken. The following precautions are put into action. 1. The liquid level must be maintained using distilled water to ensure that the electrodes are not exposed. Here, the liquid level must be what? Maintained. Otherwise, once the electrodes are exposed, then the working is going to be affected. 2. It should be charged. The cell should be charged if the relative density of the electrolyte goes down to 1.125. 3. The battery terminal should be kept clean. Sometimes there is, you normally see a whitish film getting deposited here in the electrode. You remove that white coating as a result of polarization. You occasionally brush it so that it is fresh for other charges. 4. Do not short circuit the battery. You know what I mean by short circuiting the battery? You just get a wire. Connect direct the positive terminal to the negative terminal. This one draws a lot of current. You know, a wire here is having very low resistance. And therefore current, instead of the charges flowing through the electrode, they will be flowing through the wire. And therefore are going to cause a lot of sparks. And therefore that one, there is a way it spoils the battery. Then, the last thing, never leave the accumulator in a discharged condition for a long time. Don't leave it uncharged for a long time. Then, we go to the last cell. The last cell is nickel, cadmium. We can use cadmium, nickel, and cadmium, or we can use nickel and iron. Okay? Nickel, iron cell. Sometimes we call them knife cells or knife what? Accumulators. Knife cells or knife what? Knife is not a knife. It is Ni refers to nickel and Fe refers to iron. So these are knife cells. You see, we're using the word cell and battery interchangeably because a group of cells what we call battery, or we normally call it accumulator. We are accumulating very many cells to form an accumulator or to form a battery. So I'll be using the word accumulator, battery, cells interchangeably. So I say the knife cell, you can say nickel iron or nickel cadmium. It is an alkaline cell. Instead of using acid cells, you can use alkaline cells on this time. This one is an electrode, and that is the positive electrode. We are saying the positive electrode is nickel hydroxide. Nickel hydroxide. And then the negative electrode is what we call iron. You can use iron or cadmium. Cadmium is another metal in the transition studies of biochemistry. So the cells, the sealed cells are equipped with jelly roll electrodes which allow current to be delivered in an efficient way. We are saying the battery is capable of delivering exceptionally high currents and they can be rapidly discharged. We are also saying the cell is tolerant to abuse such as dischargeable and over. Here, even if you overcharge or discharge for it has no problem. That's why I mean it is tolerant to the abuse of overcharging over discharging. The last thing is that it is rechargeable and it commonly used in portable devices like camera and so on. Are you getting it? So those are what we call lead acid accumulators. Advantages of lead acid accumulators over advantages of life cells over lead acid cells. We said one lasts longer. The life cells last longer. They deliver large current without serious discharge damage to the cell. The electrolyte never needs attention, and then it is portable. Disadvantages: when fully charged, it has a low voltage of 1.25, whereas the other dual cell has 1.5 volts, and this falls continuously on discharge. Okay, now the last thing is charging an accumulator. How do we charge an accumulator? Very simple. We do a charging circuit. Charging circuit, put there the ammeter, and then you put there the accumulator you want to charge, and then connect it to a DC supply. And then we can use a rheostat to adjust the current. This is the test accumulator. So how do we do it? We get the positive of the accumulator connected to the positive of the DC supply. Are you getting that? And then the negative of the accumulator connected to the negative of the DC supply. The positive and negative terminals of the accumulator are connected to the positive and negative terminals of the DC supply. The supply must be direct current of greater EMF than the accumulator. Must be direct current of greater EMF than the accumulator. We're going to now say, how come the battery charging their thing they are using this alternating current? The gadget which they are using for discharging converts the alternating current to direct current, and therefore you can now discharge. The next thing is that the current is adjusted using a rheostat to the recommended value. Usually each battery has a value. Okay? If it is, we are going to discharge a battery of 12 volts, so we adjust what? To a current corresponding to 12 volts. Then you charge, you switch on until gassing occurs. Gassing, it means it makes noise. Okay? Then when gassing occurs, then it is fully charged. That is the simplest process of what? Charging. So I said other batteries that we may not handle on our syllabus include lithium batteries like these ones that are used in phones, laptops, and other lithium cells, zinc mercury oxide batteries, air depolarized batteries. All those are other batteries that we handle. Okay, now the activity for you today is indicated there. I don't know whether I've seen it. You will look at that activity. It is having few questions. it may not be well indicated very well, but I'll be sending the activity on the platform. This one was not well edited. I will be sending the activity soon, and then you try before the next lesson. In our next lesson, we are going to be beginning current, definition of current, ampere, potential difference. Then we talk about Ohm's law, and so on. So I thank you for sharing knowledge with me. Wish you the best of luck. Thank you so much. Assalamu alaikum warahmatullahi wabarakatuh.
Finished.